Okay, so the question was, in the book, they had a slope for formula, which was y2 minus y1 over x2 minus x1. Okay, so that was what I skipped in my lecture yesterday. And the question was, can you use that in this? And so the short answer is no, don't use that. Now, what I was going to do is I was going to show you, if I've got this here, okay? If I pick those 2 points, even though they look like they're on the line, so they look like they would be good estimates, right? If I go through this whole thing, it's going to give me a slightly different equation, okay? Very similar, but slightly different. When I go through this thing, the residual squared, that number is going to be higher than 49.875. So I was going to do that, but I ran out of time yesterday. That's why they have that in there. The purpose of that is to show you that this is the best method, and if you use your old Math 1010 method, that method's not as good. It's close. Well, it's close if you pick 2 points that are on this line, but this line is this equation, and they are using the ordinary least squares method. So even if I pick 2 points, see that's just slightly above the line, and that's just slightly above the line. So it's off just a little bit. The residual squared is going to be higher, so that means it's not as good of a method. And I meant to do that yesterday, I just ran out of time. So I wanted to make that clear. And I can do it if you don't have any more homework questions, just to show you that it's not as good. Would you like me to do that? Okay, all right. So here's what we're going to do. We're going to pick this point here, which is the 99. We're going to pick this point here. Okay. And we're going to pick this point here, which is the 105 and the 277. Okay, so these 2 points look like they're on the line, right? Okay, so we're going to use these 2 points. So this is the old Math 1010 method, and I'm going to demonstrate why it's not as good as the method I showed you yesterday. Okay, so as we do this, you remember that your slope is your y2 minus y1, so that's going to be y2 minus y1 over your x2 minus your x1, okay? So if I divide those two there, that's going to give me 3.1666. Now look, so to 3 decimals, that's the same. This has a 1, that's got a 6, okay? So the slope is very similar. Now, if I use the equation y minus y1 equals m times x minus x1. Does that look familiar to everybody? That's the point slope formula. So what I'm going to do is I'm going to do this. I put yq, y1. Okay. So if I write this as y minus y1, it doesn't matter which point I pick, I'll pick that one. So y minus 277 equals m, which is 3.166666, times x minus, let's see, I picked 277, so 105. Okay. So this is my new equation, and in fact, I'm going to add the 277 to the other side. So they get a y equals this plus 277. That's going to make my, so we're going to do the same thing that we did yesterday, but with this new equation, just to prove that it's not as good. Okay. All right, so to do this, I need to find the predicted here. Okay, so the predicted is now going to be my slope times whatever my thing is here, 100 miles an hour, minus 105, plus 277. Okay, so the predicted with the ordinary least square regression was 260.814. This time I get 261, so it's a little bit higher, which doesn't surprise me because that dot's a little bit higher than my line, right? Okay, so I'm going to do that. Oh, I need to F4 my slope here. I'm going to do that for all of these points. Now I'm going to do my residual, which is basically the actual minus my predicted. Okay, so we were off 3.8 yards, now we're off 4.1 yards. Okay, I'm going to do this for all of these. Okay, now look, that one was right on the money. That one was right on the money. So on these two, it was actually better, but on this one, it was worse. Anyway, I'm not going to eyeball all those. That one, it was worse. So the question is, so it's better on some, it's worse on others. Okay, so now we're going to do the residual squared. Okay, and we're going to compare this sum versus this new sum. So I'm going to take this number, I'm going to square it, I'm going to copy that down, and I'm going to find the sum, and I'm telling you that I'm going to get a number greater than 4950. So it's close. It's not bad, but it's not as good as the ordinary least squares regression. And so that's what the book was going to do. And I would have done that yesterday in class, but I ran out of time, so that's why we're doing it today. Okay, so don't use that slope formula, even though it's the one you remember. Okay. All right, so I'm going to stop recording here.